In this video, you'll learn how to work with rasters in ArcGIS Pro. We'll start with a blank ArcGIS Pro project and add data and layers into it to complete some basic processes using both geoprocessing tools and raster functions. Here we have our blank map project. We have a map, but it's empty. There's no layers listed in the contents pane. Over in the catalog pane, we can click on the small triangle to expand the folders section, and you'll see the Planetary Image Analysis project folder listed. This is the home folder for my project, and if I click on the small triangle, I can expand it and view its contents. You may find times when you're working on projects you need to access a different folder than what's already present in the catalog pane. To do this, you'll right-click the Folders heading in the catalog pane and select Add Folder Connection, and then you can navigate to whichever folder you want to access and select it, and that will add it to the list, and then it will show up here in your folder connections. To begin working with the map, I need to add data. Over in the catalog pane, I can expand the data section of my folder and then click on that small triangle and expand the rasters folder and view its contents. I'm going to start by working with this Jezero ortho mosaic. To add it to the map, I can either click and drag it into the map, or I can right-click it and select Add to Current Map. This raster is now added to my map, and I can see the image displayed in the map window and see it listed in the contents pane. This image is from the Mars Reconnaissance Orbiter Context Camera, or CTX. It shows a portion of Jezero crater on Mars, which is where the Mars 2020 Perseverance rover landed in February 2021. For this exercise, I'll be working in the Jezero crater region and looking at the Perseverance rover landing site using some basic geoprocessing tools and raster functions. When you're working on a GIS project, it's not uncommon to end up with a lot of layers in your map. You can organize and group these layers in the contents pane. So to start organizing our map contents, at the top of the contents pane, I'm going to right-click the map and I'm going to select New Group Layer. Group layers can hold several different map layers and even subgroups within those, which helps you better organize your data. So now that I have the new group layer listed in the contents pane, I want to give it a helpful name. To rename it, I can click it and hover over it to activate the text. And I'm going to name this group Rasters, since it's going to hold all my base map data. And then I can click and drag my Jezero ortho mosaic into that group. And to see the group contents, you click on the triangle to expand it. So you can click and drag map layers to move them in and out of the group layers at any time while you're working. But in the future, if you ever wanted to quickly group multiple map layers that are already in your map, you can also use Control and click to select the layers all at the same time, and then right-click and choose Group, and it will automatically create a new group and stick those selected layers right into it. For planetary mapping, it's typical to have two main group layers, one for rasters, so base imagery and other pixel-based data, and then another one for the mapping features themselves, which are vector-based, so points, lines, and polygons. Group layers are really useful for keeping your data and your map layers organized, and you can also quickly expand or collapse entire groups to see their contents by clicking on the triangle next to the group layer name. You can also quickly turn all active group layers on or off by checking or unchecking the box next to the group layer name. So here, the Jezero ortho mosaic layer is turned on, and if there were other layers in this group as well and I wanted to turn them all on or off at once, I can check and uncheck the box for the group, and it will turn all of them on and off. For data products to be usable by other people, they have to contain appropriate metadata. So metadata is data about data. It's just information that describes a data set, including what it is, where it is, how it was created, how it was intended to be used, and who to contact with questions. So in short, good metadata makes it so you and others can find and make sense of an existing data set. Without appropriate metadata, data sets may not be findable, or they might be findable, but they're not usable. To see the metadata for a map layer, in the contents pane, you can right-click on the layer and select View Metadata. And this opens a new catalog tab in your main viewing area. And that catalog tab contains a list of all your map layers. In this case, I only have one right now. And if I click on it, the metadata will show up on the right. Here you can see this layer has quite a bit of information attached to it, but not all data sets are this complete. Some have very minimal to no information here, and others will have much more detailed information. One other important thing to be aware of when working in a GIS project is what map projection you're working in. Map projections are just mathematical equations for transforming a 3D body into a 2D plane like your screen. All GIS applications use projections as the method to geolocate or position your data sets. It's also how they provide their spatial analysis capabilities, like measuring lengths or orientations, and allowing you to do things like calculating the safest path for a rover to traverse across the landscape. When you're working on a project, it's really important to make sure that the projection of your map is correctly set. Fortunately, when you start with an empty map like I did here, and then I added a layer to it, ArcGIS Pro inherits the map projection from whatever the first layer is that you load into the map. So in this case, the first layer I loaded into the map was the Jezero orthomosaic, and now I can check that the projection of the map matches that Jezero orthomosaic. This is always a good thing to do, just a little sanity check before you move on to anything else. So to check this, we'll look at the map properties. In the contents pane, you'll right-click the title for the map frame. By default, this is named map, and then we'll select properties. So in the map properties window, we'll go to the coordinate systems tab. And the map frame has indeed inherited the projection from the Jezero orthomosaic layer. If I wanted to change the map frame projection, I could do that here by searching for Mars in the search box. And then I could expand and find other Mars projections here. But I want to keep it as it is, so I'm not going to touch that. Now that I know I have the map frame correctly set for my project, and I have the first map layer loaded, now I can load in other map layers, and even if they don't have the same projection as this equirectangular Mars 2000 sphere, they'll be automatically reprojected behind the scenes, and it just works seamlessly. So if a dataset doesn't correctly project when it's added to the map, it's likely that the dataset's map projection is either undefined or it's incorrectly defined. But if it's correctly defined and it's on the right body, it should just work seamlessly. One other thing that's just good to keep in mind, because ArcGIS Pro inherits the projection from the first layer that you add to the map, it's a good idea to always start with the dataset that you either trust the most or one that's defined in the map projection that you want to work in. While we're here in the map properties window, we'll take a look at one other thing. You can also change how the coordinate units are displayed in your map. This doesn't change how the data is projected, it just affects how the location coordinates are displayed at the bottom of your map window, so you can see down here at the bottom. So for example, we could change it from degrees to meters. And we do this in our General tab. You see the display units here. I can change it from decimal degrees to meters. And if you watch down here, when I click OK, it now becomes meters. You can also very quickly and easily change this right here, and you can change it back and forth as needed. It's also important to remember that by default, the coordinate display is always going to show positive east longitudes. This is a good thing to remember, especially in planetary science, because depending on what body you're working on, you may not be thinking about positive east longitudes. So going back to our Jezero orthomosaic data here, there might be times when you need to adjust how your raster image or your data is displayed. And you can do this using the tools in the menu bar up at the top of the screen. But for the right tools to show up, first you have to have your raster layer selected in the contents pane so that those raster layer tabs will show up in the menu bar. If you don't have your raster layer selected in the contents pane, so if I just select the group layer instead, you'll see those raster layer tabs are not up here. But if I select the actual raster layer, then they appear up top. So in the raster layer tab, you can change the display properties of your raster. This includes things like setting a visibility range, which are just the scales at which the layer is going to turn on or off as you zoom in and out. You can also adjust the transparency. You can access the symbology settings, and you can change the stretch, the brightness, and the contrast. Another option for the stretch is to turn on the DRA, which is the dynamic range adjustment setting. By default, stretches are applied using the range of pixel values for the entire raster, regardless of whether you're viewing the whole raster or just a small section of it. But when DRA is turned on, the stretch is automatically adjusted as you zoom and pan, and it will only use the values of the pixels within your current display extent, or the area you're currently viewing. DRA can be helpful when you're picking out more subtle variations and small-scale details that might be lost when the stretch is applied using the entire raster. So if you have a spot in a visible image that's particularly bright or particularly dark, you might want to try turning on DRA to see if that helps you pick out any features. I find it's most useful specifically for elevation data sets and helping you pick out really small, subtle elevation changes that might be lost when the stretch is applied to that whole range of elevations. But it's good to keep in mind using the DRA setting isn't always appropriate. It's going to depend on what you're doing and the data you're viewing. So knowing whether the DRA will be helpful or not usually involves experimentation and just trying it out with the specific data sets that you're working with. But it's a good thing to be aware of, and make sure also that you pay attention to whether DRA is turned on or off. So in the raster layer tab, you can also manually adjust the brightness and the contrast for your whole layer. So say I want to make it brighter, I can crank that up here. And if I want to reset the values to my starting points, I could either go in and manually change those numbers here, or you can just click the icon and it will go back to its default setting. For this example, we'll be working with a larger area than what is covered by just this image. So instead, we'll zoom out and we'll use multiple tiles of CTX imagery. When you're working with sets of images, it can sometimes be helpful to put them into what's called a mosaic dataset. A mosaic dataset is a single layer in your map, but it contains a collection of images that can be analyzed and manipulated all as one. So individual images within a mosaic dataset can also be queried and added to your map individually. And this allows you to work seamlessly with anything from one individual image to hundreds of images all at once. We'll start by creating a mosaic dataset item. And then once the mosaic dataset has been created, we can add images to it and edit its properties. So to start out in the catalog pane, we'll expand our folders to find the geodatabase we want to work in. And when you have a new project from scratch, your geodatabase is empty. In this case, 2 items have already been added to this project geodatabase, and I'm going to add additional items to it as I work. The project geodatabase is where you can store both raster and vector features for your map. And storing map features in a geodatabase allows you to very easily share them with collaborators. So let's take a look at what the geodatabase actually looks like in our Windows File Explorer here. The geodatabase is this .gdb folder when you look in the project folder in the File Explorer window. This geodatabase in Pro right here is this folder in the File Explorer. So to share my geodatabase with people, all I would need to do is zip up this .gdb folder and send it straight to my collaborator, and they can then unzip it, pull its contents straight into a GIS project, and it will look like this. If I try to access things through this folder in the File Explorer window, though, it's total gibberish. The geodatabase is only useful within ArcGIS itself, but they're very useful for zipping up and sending to a collaborator. To create our new mosaic dataset and add it to our geodatabase, we're going to right-click our geodatabase and select New Mosaic Dataset. And this will open the Create Mosaic Dataset tool. First, we'll set our output location, which is already set to our geodatabase, but it's always good to double-check this. Then we'll give our mosaic dataset a name. For the coordinate system, because ArcGIS is primarily focused on Earth-based applications, it will automatically, by default, use WGS 1984, which is an Earth-based projection. But we don't want that here. We're working on Mars. To change it, we can click this drop-down menu. And because I know that the current map is in the projection that I want, I can select Current Map. And it will automatically populate what that projection is once I select Current Map, so I can always then reconfirm that it's what I want. Next, I'm going to expand the pixel properties section and set the number of bands to 1. A basic grayscale image only has 1 band. Some data sets like color images or other spectral data might have more than 1 band, but in this case, we just have a flat, single band, black and white image. For the pixel type, this is based on the images that you're going to be adding to the mosaic dataset. And this information can be found by right-clicking on one of those images in the catalog pane. So I'll go back to my catalog pane, and I'm going to add these 4 images to my mosaic dataset. So let's right-click one of them, and then we can go to the properties. And if I scroll down here, I can see the pixel type and pixel depth. This is the information that I want. So it is an 8-bit unsigned image. And click Cancel, go back to my geoprocessing pane, and for pixel type, I will select 8-bit unsigned. And then I can click Run and create my new mosaic dataset. Once the tool is finished running, you should see a green message box at the bottom of the geoprocessing pane, which I see mine right here. And the new mosaic dataset will also now be listed in the contents pane. And if I go to the catalog pane, it will be listed under the geodatabase as well. So in the contents pane, let's click on our CTX mosaic layer and drag it up into our rasters group. And then I can also quickly collapse the symbology for these because I don't really need those visible. If I wanted to quickly collapse or expand multiple layers within a group at the same time, I can hold Control and then click on the triangle, and you see it will collapse and expand these at the same time. That works for everything that's at the same indent level on the contents pane. For example, all of the items that are within a group like we have here. I'm also going to turn off my Jezero orthomosaic layer. So the only layer that's visible on the map should be my CTX mosaic layer. Now that I have the orthomosaic layer off, I don't see anything in my map. And it could be that I'm just not looking in the right place. So to make sure I'm looking in the right place to see my CTX mosaic layer in the contents pane, I'm going to right click it and I'm going to select Zoom to Layer. This will make sure I'm in the correct place to view any data that is in this layer. But now that I've zoomed to it, you'll see there's still no images visible. And this is because the Create Mosaic Dataset tool only creates an initial mosaic dataset file. The new mosaic dataset file is empty, and I still have to add the images to it. So now I'm going to add the images. To do this, I'm going to go back to my catalog pane, and I'm going to right-click my CTX mosaic, and I'm going to select Add Rasters. In the Add Rasters to Mosaic Dataset tool, I'm going to leave all the defaults. All I need to do is set what my input data is. And to do this, I'll click on the little browse icon under Input Data. So one really nice thing that you can do here, if you have a project folder set for your project, you can click on Folders, and it will automatically take you to the project folder, which makes it really quick and easy to get to where you want to go to access your data. And now that I'm in the project folder, I can navigate to where my rasters are. Now that I'm in the right folder, you can see that nothing is showing up except this one little folder, and that's because the default display type is .csv. I need to change this to all types to see everything that's in this folder. So now that I've done that, I can see my rasters here, and I can select them all, either doing Shift-click or Control-click, and click OK to add these to my input data list. One other thing I want to set in this tool is in the raster processing section. I'll check the boxes for calculate statistics and build pyramids, and then I'll click Run. Now that my Add Rasters to Mosaic Dataset tool is complete, I'm going to go back to my CTX mosaic in the contents pane, and I'm going to zoom to layer again. And now I can actually see the CTX images I just added to the mosaic layer. Now that I have the data added, I can zoom in and out. And you notice, zoom in, everything looks great. As I zoom out, suddenly my images will disappear. The images in the mosaic dataset are only displaying when I zoom in because I haven't created the overviews yet. Overviews are lower resolution versions of the image that display when it's zoomed out. And these just improve the rendering speed of the map, and it's easier for your computer to display compared to the full res images, which have unnecessary levels of detail when you're looking at it, say, at this scale. So I've added the full res images that I view when I'm zoomed in, but I still need to create those lower res overviews. To create the overviews, I'll go back to the catalog pane, and again, right-click the CTX mosaic, and now I'm going to select Optimize, Build Overviews. In the Build Overviews tool, leave all the defaults and just click Run. Now that the Build Overviews tool is complete, I'm zoomed out on the map window and I can still see the images in the mosaic layer. So now that I've confirmed I have my overviews, I'm going to close the tool and expand the mosaic dataset in the catalog pane and turn the footprint off. So I'll uncheck this box for the footprint, and you can see those green boxes go away. And now all I see is my nice seamless mosaic of my CTX images. One of the benefits of working with mosaic datasets is that you can work with many images. So in this case here I have 4, but I could have hundreds. And I can work with them as though they're one image. To do this, I'm going to first make sure my CTX mosaic layer is selected in my contents pane. And this will make the mosaic layer and mosaic layer data tabs appear up in my menu bar. So in the mosaic layer tab, I can change, just like before with the rasters, I can change the stretch, the brightness, the contrast, I can add transparency, I can set the visibility range. And this change is applied to all of the images in the mosaic dataset at the same time, instead of just working with one image at a time. So say I want to make it brighter, I can do that, and everything changes all at once. One other thing you may want to do when you're working with the mosaic dataset is search for specific images that are within your collection. You can do this in the Data tab. There is the Raster Item Explorer or Explore Raster Items tool. In the Raster Item Explorer pane, you can set how you want to search for them. So by area of interest, you could have it be everything in the collection. You could have certain things you've selected, or you could have only things that are in your display extent. I'm also going to check a box here to exclude the overviews. So my search will only return original images and not the original images and each of their overviews. So now that I've set those, I'm going to click Apply to update my search. And now that Raster Item Explorer list contains the 4 original CTX images that I added to the mosaic dataset. I can also change how these results are displayed to make them a little more helpful. So I can click the Configure Results tool here. And I'm going to change the first field, the object ID. I'm going to change that to the name, and I'm going to turn on thumbnails. So the individual CTX images are now shown with the thumbnails and the file names. Let's expand this a little so we can see it more. So I have my file names here, and I also have my thumbnails. And configuring how these results are displayed can make it easier to explore your mosaic dataset items. So if you're working with data that had other identifying information, you could use the Configure Results tools to show those as well. From this list, I could add individual images to my map. This could be helpful if I have a large collection of images and I only need to work with one or a few of them individually. So the Add to Current Map icon is available for each mosaic dataset. When you hover over it, you can see it right here. That little yellow with a plus. I can click that to add any individual image to my map. If I wanted to add multiple images to my map, I could check the boxes for each of them, and then I could click Add to Current Map at the toolbar at the top of the list. For this example, I'll be working with the whole mosaic dataset, so I don't need to add any individual images to my map, so I can close the Raster Item Explorer and just return to my catalog pane. Often in planetary science, you'll work with elevation data in the form of DEMs or DTMs. These can provide really valuable insights into a region and are very often used for things like terrain analyses, like landing site assessments. For this analysis, I'm going to use a subset of a global Mars DTM. So to begin, I'll add the elevation data to my map. This DTM is the MOLA HRSC Global DEM, which uses a blend of the European Space Agency's High Resolution Stereo Camera, or HRSC, and NASA's Mars Orbiter Laser Altimeter, or MOLA, elevation data. Sometimes you might find that you want to rename something in your contents pane. You can do that by clicking and hovering, and then typing in the name you want, pressing enter. Often datasets come with names that aren't very intuitive, but you can rename any map layer within the contents pane over here for clarity. This doesn't change the original file name. Instead, it's changing what's called the alias, which is essentially a display name, or what the dataset is called in the contents pane. So every dataset has a file name and an alias. It's important to remember actual file names, which are something like these over here in your catalog pane. They can't include spaces. That's why these have dashes and underscores. But aliases can include spaces. So that's why right here I have a space in this alias and it works just fine. To change an alias, you would do that in the contents pane like I just did with my DTM. To change a file name, you would do that in the catalog pane, and you would do that by right-clicking and selecting rename. But this changes the actual file name itself, so that's important to remember. Now that the DTM is added to the map, I'm going to drag it into my rasters group. And I'm going to put it on top of the other rasters so we can display the elevation data on top of those images. But to be able to see the images below the elevation data, we need to change its transparency. We can do this in the raster layer tab, but first, there is no raster layer tab up top. That's because I don't have my DEM selected, so I'm going to select it, and now my raster layer tab appears. So we'll set the transparency to 60%. And now the DTM layer is transparent and the underlying base imagery is visible, but the current symbology for the elevation data is set to grayscale, which really isn't very useful for visualizing it on top of a grayscale image. So to change the symbology, I can either click on the symbology icon in the raster layer tab, or you can right-click the layer in the contents pane and go to symbology. This opens the symbology pane, which is where you can change the symbol type, the color, stretches, and a lot of other options for how your data is displayed. So in the symbology pane, I'm going to open the color scheme drop-down menu. And the first thing I'm going to do is check the boxes for show names and show all. There are a lot of color schemes available, and they aren't all listed unless you check show all. First, let's just create a custom color scheme to see how we can do that. So I'm going to use heat map 3 as my starting point. And this is a preset color scheme, but any preset scheme can be modified by then going back to your color scheme drop-down menu and selecting Format Color Scheme. So in that color scheme editor, now I can change the color scheme to anything I want. So I can select different colors. In the middle here, let's put in a hot pink. And I can also remove steps. I could also add a step if I wanted to. And here, let's make this orange. You can also switch the order if you want to reverse your color scheme. So now that I've finished perfecting my beautiful color scheme, I can click OK to apply the changes, and I'll see them immediately reflected in my map and in the symbology icon over here. So now that I've experimented with making this beautiful custom color scheme, I'm going to set the actual color scheme for my DTM layer. So I'll go back to the color scheme drop-down menu, and this time I'm going to select Civitas, which is a blue to yellow color ramp. It's important to note that many commonly used color schemes, especially those that are often used for elevation data, are not colorblind friendly. For this tutorial, I'm using the Civitas color scheme, which is a blue to yellow color ramp. There are others that are also colorblind friendly. But when you're deciding on symbologies, it's really important to consider color blindness and other visual impairments and make sure that you are not only using accessible colors, but also when you're working with point data, be sure to use different shapes as well. So for example, blue circles and yellow triangles. That way there's more than one way for people to differentiate between the different features, and it's not just based on color. There are a lot of color vision simulators and colorblind accessible palette generator tools available and other resources out there that you might find useful. There's also an ArcGIS plugin available called the Color Brewer Schemes that can help you identify colorblind friendly schemes within ArcGIS. One more quick tip before we leave the symbology menu itself. Often you might come across images that have a black border or background that you need to remove so you can display them on top of other images. And you would do this here in the symbology pane. Down at the bottom, you go to the Mask tab. And in future projects, if an image has a black background that you want to remove, you go here and check this Display Background Value box. This sets the background value to have no color, so it's saying my background value, I want it to be displayed as transparent. And that will remove that black background that is on your image. So now that we have our elevation symbology set, I'm going to close my symbology pane and go back to my catalog pane. The DEM I added to the map covers a large region of Mars, but at the current scale, I can only see a small portion of it. So to zoom to the full extent of my data, I can go back to the Map tab and I can click on the little globe. Since the DEM is the most expansive data set in my map, I could also accomplish the same thing by just right-clicking my DTM layer and going Zoom to Layer. Same idea. Now that I can see the full extent of my elevation data, I can also see that it includes way more data than I need to work with, because for this activity, I'm only going to be working within the region of the CTX mosaic layer, which is substantially smaller than the whole elevation data set. So instead of trying to process the entire DTM, I can clip this dataset to just the area where I'll be working and save myself some time and effort. First, to start clipping the DTM, I'm going to need to open the geoprocessing tool pane. This is in the Analysis tab of your menu bar up top. You'll see the Tools icon here. You click on the Tools icon, which opens your geoprocessing pane. The geoprocessing pane has a lot of the data processing and analysis tools that you might need when you're working in ArcGIS Pro. This pane has 3 tabs, so there's Favorites, Toolboxes, and Portal. It doesn't matter which tab you're in, you can always quickly search for a tool using the Find Tools search bars up at the top of the geoprocessing pane. The Favorites tab contains a list of any tools you've saved as a favorite, and also a list of your most recently used tools. The Toolboxes tab contains a full list of all the geoprocessing tools that are available and groups them by which toolbox they're in. In this tab, you can manually click through the different toolboxes to access any geoprocessing tool, but you do need to know which toolbox it's in, so sometimes that can be a little slow. The Portal tab lists any geoprocessing tools that are available to you through your organization's web portal, but really in most cases, you'll be in the Favorites tab and you'll just use the search bar to find tools, since that's often the quickest and easiest way to access them. But in the search bar, I'm going to start by searching for clip, and I'm going to click on the Clip Raster tool to open it. In my Clip Raster tool, I'm going to set my input raster to my Certus DTM layer, and my output extent, or what I want to clip it to, is going to be the CTX mosaic boundary. I want the full boundary of the CTX mosaic layer. I'm also going to check the box for Use Input Features for Clipping Geometry, because I want to clip my DTM to exactly this boundary. If this box is unchecked, the raster will be clipped, but it will be clipped to the minimum bounding rectangle of whatever I have set as my output extent, which means it might leave extra around the outside, and I don't want that in this case. So I also need to set my output raster dataset. It's always good to check where exactly it's saving your output. By default, ArcGIS Pro will save things to the project geodatabase when it's outputting new rasters. So in this case, you can see it's going to my geodatabase. If I wanted to be able to share this clipped image with someone else, I would want to change this to my rasters folder or some other folder, not the geodatabase, so it outputs an actual file rather than putting it into that geodatabase. In this case, the geodatabase is fine. I'm not planning on sharing this with anyone, so I'll just leave that, and I'm going to change the name of the output file itself. And now that I have those set, I'll leave all the other automatically populated settings, and I'm going to click Run. With my Clip Raster tool complete, my new DTM has been added to the map, and I can close my geoprocessing pane. With my clipped DTM, I no longer need my huge DTM, so I'm going to turn that other one off. And let's put my new DTM in my rasters group. And now I'll zoom to my new DTM. When I clipped the DTM, the new map layer was automatically given the default grayscale symbology and 0% transparency. So just like before, I need to go and change my symbology and add transparency. So I'm going to go to my symbology pane, and I'm going to once again select the Civitas color scheme. You might notice the color distribution for the new Jezero DTM map layer is different than it was when we were looking at the Certus DTM map layer, the larger area DTM. If I turn the previous one back on, you can see how different the color range is in this area. And this is because the color ramp is applied using the full range of pixel values in that map layer. So it's the same color ramp that's being used, but the Certus DTM, or the larger area DTM, has about 10,000 meters of elevation change that color ramp has to cover. And now with the clipped DTM, with this clipped to the smaller region of interest, we're now only working with about 4,000 meters of elevation change. So that color ramp is compressed, and you can see a lot more detail. One way you can work with raster data in ArcGIS Pro is using raster functions. Raster functions are tools that process your data on the fly and only within the area that you're currently viewing. Unlike geoprocessing tools, raster functions don't create a new data layer. So instead, they temporarily apply the process directly to the pixels of the original data layer. This makes raster functions really useful for quick analyses or experimenting with settings, since they only process the data that you're viewing and they don't take up additional computer storage space. Raster function results can also be exported and saved as needed. So if you find something you like the settings, you have gotten it to the point where you want to actually save a copy of something, you can export it. In addition to single-step analyses, raster functions can also then be chained together to create custom functions that can be saved and used again and again. In this example here, I'm going to use raster functions to do some basic terrain analysis on this area where the Mars 2020 Perseverance rover landed. So I can access the raster functions menu through the imagery tab of the menu bar. Go to the imagery tab and there's our raster functions icon, which opens the raster functions pane. Similar to the geoprocessing tools pane, you have multiple tabs in your raster functions pane. You have project, system, and custom. The project tab shows any custom raster functions that you have saved specifically within the current ArcGIS Pro project. The system tab lists all the raster functions that come with ArcGIS Pro. And the custom tab lists all the custom raster functions that you have saved that are not tied to a specific ArcGIS Pro project. By default, the system tab will be open when you open the raster functions pane, and this is generally where you will work. At the top of the system tab in the raster functions pane, you can search for raster functions by name. I'll start by searching for hillshade. And then I have the hillshade icon right here. Click on that to open the hillshade raster function. Hillshades are really useful for visualizing the terrain in an area and are often used in planetary science. We really like to display them underneath other layers. It helps give a nice depth to them. And I'm going to use my DTM to create a hillshade of this area using raster functions. So in my raster function pane, I'll set the raster to the Jezero DTM, and I'll leave all the other default settings, and I'll click Create New Layer. When the raster function is complete, that layer is automatically added to the map. And the raster function quickly processes only the data that are within my current display extent. So if I had a really big DTM, it would still be pretty fast because it would only be processing what I'm viewing. It's important to remember, though, as you move around in your scene or you zoom in and out, it reprocesses every time. So if you have really large data sets or very large file sizes, it may start to get bogged down depending on how much of your data set you are actually viewing at any given point in time. Raster function outputs are automatically named using the raster function and then the input layer. So this is hillshade Jezero DTM. I'm going to collapse this layer and I'm going to turn it off for now. And since hillshades are often displayed underneath other data layers, I'm going to put it down at the bottom of my raster group. Another really useful piece of information for terrain analyses and things we like to look at for landing sites is slope. I can quickly calculate the slope across my area of interest using raster functions. So in the slope raster functions, I'll set the DEM again to the Jezero DEM and leave all the other default settings, and then I'll click Create New Layer. And my slope analysis is now done. My slope Jezero DTM layer has been added to the map. And to begin, this layer was given the default black and white color ramp and 0% transparency, which is not ideal for visualizing. So I'm going to click on it in the contents pane and go to my raster layer tab and give it some transparency. And then we'll also go to the symbology pane. And let's change this color scheme to yellow, green, blue. So now that I've updated the symbology for my slope layer, let's turn off the DEM so we can see it a little better. At first glance, the entire area appears to be one color, but the slope color scheme covers everything from 0 to 90 degrees. And despite the variations in topography in this area, the majority of this area has slopes that are less than 30 degrees, which doesn't show up well with this current symbology. Everything is down here in this yellow range. Slope is often used in terrain assessments for landing sites, so let's look at it through that lens here. When you're searching for appropriate landing sites, candidates are limited to slopes that are less than 15 degrees, with slopes of 0 to 5 degrees being ideal. And the current color ramp style symbology, it's really difficult to pick out what areas lie within those constraints. So we'll change the symbology so it's easier to see what is actually within that ideal slope range. So in the symbology pane, it's currently set as a stretch. I'm going to change this primary symbology to classify. You might be prompted to create a histogram. We'll click yes. And now you can see the layer symbology immediately changes in the contents and the symbology panes. Since we're looking at this in terms of acceptable slopes for landing sites, I'm going to change the number of classes to 3. That way I can separate it into acceptable, marginally acceptable, and unacceptable. I also need to change the color scheme back to yellow, green, blue, since it goes back to a default color scheme when you change your primary symbology style. So now my slope Jezero DTM layer shows 3 slope classes in pale yellow, teal, and dark blue. But the groupings for these classes have been automatically generated and they don't yet match the cutoffs that I want for my landing site selection. So I still need to change those upper value numbers right here, which will set my bins for the different slope classes. In the upper value column here, I'm going to just work through and set these. For my first class, I'm going to set my upper value to 5. For my second one, I'm going to set my upper value to 15. And for the third one, I'm going to set my upper value to 90. And what that did here for this first class, it took everything and said anything from 0 to 5 degrees goes in this category. In this one here, I said anything that is greater than 5 degrees and up to 15 degrees goes in the second category. And anything that is greater than 15 degrees all the way up to 90 degrees goes to this third category. I'm also going to change my labels here, which is what's displayed as the text next to the color. I can click and hover again. These are acceptable for my first class. My second class, which is the 5 to 15 degrees, is marginally acceptable. And my third class, which is greater than 15 degrees, is unacceptable. You can see those have also now changed over here in my contents pane. So now that I have these changes applied, the slope layer now shows all the areas that are acceptable for landing site selection in pale yellow, with areas that have marginally acceptable slopes or 5 to 15 degrees in teal, and the unacceptable slopes or slopes that are greater than 15 degrees are shown in dark blue. And you can see there are some areas with some dark blue in here in this crater. You have all 3 here. And if we go to where the Perseverance rover actually landed, it's this area right in here, which is in the pale yellow area as we would expect. So in this exercise, you learned the basics of working with rasters in ArcGIS Pro, starting with adding raster data to a map project and modifying its display properties and symbology. You also learned how to create and add rasters to and work with a mosaic dataset using a collection of CTX images over Jezero crater on Mars. And you then learned how to use both geoprocessing tools and raster functions to process and analyze a set of raster data in this region.